Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with an isometric 3D projection of an engineering object into which the front view face, the top view face and the left hand side view face of the object, they have been appropriately combined into a single 3D isometric projection over here. Now using the constructional details of this engineering object, we are required to obtain the front view orthographic projections, the top view orthographic projections and the left hand side view orthographic projections of the solid. In order to obtain the orthographic projections of the solid, we need to evaluate the dimensions of the front view face, top view face and the left hand side view face corresponding to the solid. Now when we look at the solid from the front view orientation, so we observe that the width of the solid happens to be equal to 50 millimeter, while the height of the solid, it happens to be 40 millimeter. So the dimensions of the front view face of the solid happens to be 50 millimeter width and 40 millimeter height of the solid. When we look at the solid from the top view orientation, once again we observe that the width of the solid happens to be 50 millimeter, while the depth of the solid happens to be equal to 35 millimeter. Here we have got the depth of 10 millimeter corresponding to this rectangular slot at the rear side of the solid. Corresponding to this width, we have got the depth equal to 10 millimeter, and again corresponding to this rectangular slot, this depth happens to be 15 millimeter. So the total depth of the solid happens to be 35 millimeter. Therefore, the dimensions of the top view face corresponding to the solid will be measuring 50 millimeter width and 35 millimeter depth of the solid. When we are going to look at the solid from the left hand side view orientation, so we observe that the depth of the solid, it is equal to 35 millimeter, while the height of the solid happens to be 40 millimeter. So the left side face of the solid will be measuring 35 millimeter depth and 40 millimeter height of the solid. Now we will proceed to evaluate the orthographic projections of the solid. So in order to obtain the orthographic projections of the solid, we have drawn the XY reference line, the X1, Y1 reference line, and we have also obtained a transfer line originating from the intersection of XY reference line and the X1, Y1 reference line, and this transfer line, it is inclined at an angle of 45 degree with respect to the XY reference line, and this transfer line we are going to use in order to transfer the distances alongside the depth of the solid from the top view orthographic projection view into the left hand side view orthographic projection view over here. Since we are going to obtain the orthographic projections of the solid using the first angle projection method, therefore the front view orthographic projections will be obtained above the XY reference line. The top view orthographic projections of the solid will be obtained below the XY reference line, while the left hand side view orthographic projections of the solid will be obtained on the right hand side of the front view projections above the XY reference line. Now let us proceed to evaluate the dimensions of the front view orthographic face of the solid. So we know that the dimensions of the front view face will be measuring 50 millimeter width and 40 millimeter height of the solid over here. So here we have obtained two vertical projector lines separated by a distance of 50 millimeter into the front view projection view and this distance of 50 millimeter, it is corresponding to the width of the solid over here. So here we have got the width of the solid equal to 50 millimeter, and these two vertical projector lines, we have appropriately extended them into the top view projections as well, because into the top view projections also we are going to require the width of the solid equal to 50 millimeter over here. Now we also know that the height of the solid happens to be equal to 40 millimeter. So now we are going to mark a distance of 40 millimeter above the XY reference line, and we have obtained a horizontal projector line parallel to XY reference line into the front view orthographic projection view, and we have extended this horizontal projector line appropriately into the left hand side view projections over here, because into the left hand side view projections also we are going to require the height of the solid equal to 40 millimeter. So having obtained the front view face of the solid, now let us obtain the top view face of the solid over here. So we know that the width of the solid into the top view, it is equal to 50 millimeter, which we have already obtained, and the depth of the solid, it happens to be 35 millimeter. So now we are going to draw two horizontal projector lines into the top view orthographic projections separated by a distance of 35 millimeter, which happens to be the depth of the solid over here. And these two horizontal projector lines, we have appropriately transferred them into the left hand side view projection view over here using this transfer line in such a way that the distance between these two vertical projector lines into the left hand side view projection view will be equal to depth of the solid, which happens to be 35 millimeter. So this way we have been able to obtain left hand side view face of the solid, which is measuring 35 millimeter depth of the solid and 40 millimeter height of the solid over here. So now let us proceed to evaluate the front view orthographic projections corresponding to the solid. So to begin with, we are going to evaluate different elements of the solid alongside the width of the solid over here. So as we look at the solid from the front, so we observe that there is a vertical web which is lying centrally alongside the width of the solid, and this width of the central web happens to be equal to 10 millimeter, while there are two rectangular slots which are measuring width is equal to 20 millimeter on either side of this vertical web. So now in order to draw this particular web, we need to measure distance of 20 millimeter from the right hand side surface of the solid, and again 20 millimeter from the left hand side surface of the solid. So now we are going to mark a distance of 20 millimeter from the right hand side face of the solid, so that this edge of the vertical web can be defined into the front view projections over here. So having measured this distance of 20 millimeter from the right hand side face, we have obtained a vertical projector line into the front view projections, and we have appropriately extended this vertical projector line into the top view projections over here. Similarly, corresponding to this rectangular slot onto the left hand side portion of the solid, again we are going to measure a distance of 20 millimeter from the left hand side face of the solid. Again we have marked a distance of 20 millimeter from the left side face of the solid, and we have obtained a vertical projector line into the front view orthographic projection view, and we have extended this vertical projector line appropriately into the top view projections over here. Next we have got these two elements, because we observe that at the base we have got a rectangular slot, and this width of this vertical leg onto the right hand side and this vertical leg onto the left hand side. So this width is also 10 millimeter and this width is also 10 millimeter. So now from the left hand side face of the solid, we are going to measure a distance of 10 millimeter. So here we can check, as we move away from the left hand side face of the solid and measure a distance of 10 millimeter, we will be obtaining a vertical projector line into the front view projections, and we need to extend this vertical projector line into the top view projections as well. Similarly, corresponding to this vertical web of the solid, so again we are going to measure a distance of 10 millimeter from the right hand side face of the solid. So from the right hand side face of the solid, once again we are going to measure a distance of 10 millimeter, and we will be obtaining a vertical projector line into the front view projection over here. And this vertical projector line, we have appropriately extended it into the top view projections as well. And another thing we need to observe, that here we have got a vertical leg into the front face, and again we have got a vertical web over here corresponding to this rectangular slot. So one vertical web is lying onto the left hand side, another vertical web is lying on the rear side of the solid, which is lying towards the right hand side face of the solid. And once again, the distances of these two vertical webs, they are lying at a distance of 10 millimeter from the left hand side face and the right hand side face respectively. So this distance of 10 millimeter will be overlapping with this distance of 10 millimeter. Similarly, this distance of 10 millimeter will be overlapping with this distance of 10 millimeter. So this way, all the elements alongside the width we have already plotted into the front view orthographic projections. Now let us proceed into the direction of the height over here. So here we can check 10 millimeter from the base. Here we have got a rectangular slot available over here into this object. Now we are going to mark a distance of 10 millimeter above the XY reference line corresponding to this edge of the rectangular slot over here. And now we are going to obtain a horizontal projector line into the front view projections, and we are going to extend this horizontal projector line appropriately into the left hand side view projections as well. Now we also observe that this height corresponding to this horizontal surface and this horizontal surface, it is equal to 20 millimeter from the ground. So once again we are going to measure a distance of 20 millimeter from the ground, and we will be obtaining a horizontal projector line into the front view projections, and we need to extend this horizontal projector line appropriately into the left hand side view projections over here. So this way, all the elements corresponding to the width and height, they have been obtained appropriately into the front view orthographic projections. So let us darken those surfaces which are visible to the observer, as the observer is going to look at the solid from the front view orientation. Now we can see, as the observer is going to look at the solid from the front, so this boundary of the solid will be visible to the observer over here. So this is the boundary of the solid which will be visible to the observer, as the observer is going to look at the solid from the front. And then we can see this is a vertical web which is lying over here. So this vertical web, it is lying over here, and it is lying at a distance of 20 millimeter from the base over here. So this way, here we can check, this is a Y-shaped surface. This web, it is having shape of a Y. So as the observer is going to look at the surface, this Y-shaped surface over here, so the observer is going to obtain the true shape projections corresponding to this Y-shaped wave into the front view projections. Why? Because this surface happens to be parallel to the vertical plane. So we are going to observe the true shape projections corresponding to this Y-shaped wave into the front view projections over here. Corresponding to this rectangular slot, we are going to observe true shape projections of this rectangular slot into the front view projections over here, because once again this surface or the open surface, it is again parallel to the vertical plane. So we are going to obtain true shape projections corresponding to the slot over here. Then again we have got two surfaces over here. One surface is lying towards the left hand side and another symmetrical surface is lying onto the right hand side. So both of these surfaces, since they are being parallel to the vertical plane, so we are going to obtain true shape representation of these two vertical flat surfaces into the front view projections over here. And another thing we should observe, there is a rectangular slot which is lying towards the rear side of the solid over here. So this surface and this surface, both of these surfaces, they are available at a distance of 10 millimeter from the right hand side surface and at a distance of 10 millimeter from the left hand side surface of the solid over here. So here both of these surfaces, they will not be visible to the observer from the front view orientation. So observer will be able to view the edge views of both of these surfaces into the front view projections at a distance of 10 millimeter from the right hand side wall or the surface of the solid and 10 millimeter from the left hand side surface or wall of the solid. So this way, these two surfaces which are not visible to the observer from the front view orientation over here. So this way we have been able to obtain the orthographic front view projections of the solid. So now let us proceed to evaluate the top view projections of the solid. Now we can see that we can divide this solid into three parts. One is this rectangular slot at the back, and this rectangular slot is having depth is equal to 10 millimeter. Then we have got this Y-shaped web, and the depth of this Y-shaped web, it is equal to 10 millimeter. Then we have got this rectangular slot on either side of the web, which is again having depth is equal to 15 millimeter. So this web is also having depth equal to 15 millimeter. So we can divide this depth of 35 millimeter over here into three segments. 10 millimeter corresponding to this rectangular slot, 10 millimeter corresponding to this Y-shaped web, and 15 millimeter corresponding to this surface over here. So here mark these three distances over here, and we will be obtaining two horizontal projector lines into the top view projections, and we have appropriately transferred using this transfer line these two projector lines into the left hand side view projection view over here. So this way we have been able to obtain the grid matrix corresponding to different elements of this particular solid into the top view projections over here. So now let us start joining different elements of the solid which are visible to the observer as the observer is going to look at the solid from the top view orientation over here. So now as we look at the solid from the top, so we are going to observe this Y-shaped web as a true shape projection projected onto the horizontal plane, because this Y-shaped web, it is parallel to the horizontal plane. So it has been projected as a true shape projection in the top view projections over here. Similarly, we have got corresponding to these two rectangular slots over here, these two rectangular surfaces available at the top surface of this horizontal web over here. So now we can see that this surface as well as this surface, which is measuring 20 millimeter width and 15 millimeter depth over here. So these two symmetrical rectangular surfaces which are available with us towards the front side face of the solid, it is this surface and this surface over here. So both of these two symmetrical rectangular surfaces, they happen to be parallel to the horizontal plane. So into the top view projections, we have been able to obtain the true shape projections corresponding to these two rectangular surfaces over here. Then another thing we need to observe over here we have got a rectangular slot at the bottom horizontal web. This is the bottom horizontal web. So into this bottom horizontal web, here we have got a rectangular slot being provided over here. But this slot is not visible to the observer from the top. So we are going to observe dotted line projections corresponding to this vertical edge and this vertical edge of this particular rectangular slot over here. So here we can check two vertical edges corresponding to this wall and this bottom wall over here corresponding to this rectangular slot will be observed in the form of hidden lines into the top view projections over here. So this completes the construction of the top view orthographic projections of the solid. Now when the observer is going to look at the solid from the left hand side view, so observer will be able to witness the true shape projection of this L-shaped surface which is available towards the left hand side portion of the solid. So now the observer will be able to witness this L-shaped surface which will be a true shape. Why this is true shape? Because this L-shaped surface, it happens to be parallel to the profile plane over here. So profile plane will be lying over here. So this surface will be projected as a true shape onto the profile plane, and besides this surface there is another rectangular surface available over here, and this rectangular surface, since it is also parallel to the profile plane, so we are going to witness the true shape projections corresponding to this rectangular surface projected onto the profile plane over here. Then another thing we need to observe over here, there are two slots. One is a vertical slot, another one is a horizontal slot. This horizontal slot is available at the base of the solid, 10 millimeter above the base. So here the hidden line projections will be available up to this point over here. Again we have got a vertical rectangular slot available toward the rear face of the solid. This is the front face, this is the rear face of the solid, and then this edge and this vertical edge. So both of these two vertical edges, they are going to overlap with each other, and a dotted or a hidden line projection up to this point, because this slot or this edge, it is not visible to the observer from the left hand side view. So one hidden line projection up to this point, another hidden line projection up to this point, it will also be available. So here we have to draw two hidden line projections over here. One hidden line projection, it is corresponding to the vertical slot which is lying toward the rear side of the solid. It is represented by this hidden line. Another horizontal hidden line projection corresponding to a rectangular horizontal slot which is available onto the base of this solid over here. So this way, two hidden line projections we have been able to obtain into the left hand side view projections over here. So this completes the construction of the left hand side view projection of the solid. So this way we have been able to obtain the front view orthographic projections, the top view orthographic projections, and the left hand side view orthographic projections of a solid when the 3D isometric projection of the solid depicting various constructional details of the object, it had been provided to us. So this is all for today. So we will be continuing with further discussion regarding few more illustrative cases of orthographic projections of the solids in the coming lectures. So thank you very much. Thanks a lot.